Many functions are neither even nor odd. Let's take a look at one of those functions. So we have f of x is equal to 2 raised to the x power. So let's go through our test for the even and then our test for the odd, and then we'll take a look at the graphical approach. So let's pick a test point of 2. So our test point is positive 2. So we need to, for this even condition, we need to test f of negative 2 equals 2 raised to the minus 2 power. We remember from our rules for powers that this negative 2 will bring this entire thing down into the denominator so that it will become 1 over 2 squared, which is equal to 1/4. And then we need to test f of positive 2. So f of positive 2 is equal to 2 squared, which is equal to 4. So this is not equal to this. 1/4 is certainly not equal to 4, and so this thing is not even. So let's test the second part, which is, let's test the second condition. This condition is for the function to be odd. So we have f of negative 2. You always start with that. And we found it here to be 1/4. And then we need f of 2. But what we're looking for is negative f of 2. So this is negative f of 2. And this is equal to negative. And then f of 2 is equal to 4. So this is negative 4. So 1/4 is not equal to negative 4. So this is not odd. So this one is neither. We can see that clearly if we take a look at the graph. Looking at this graph here, we discussed last time how we can take the portion of the graph that's on the positive x side and rotate it around, and if it fell right on top of itself, then it would be even. But we see that when we rotate this over, it falls like this. And so that's not even, because it doesn't fall on top of itself. And then for it to be odd, we have to flip it one more time about the y-axis, or about the x-axis rather. And when we do that, we see that it does something like this. So it's not matching up with that condition either. So this function is neither. Question, can you think of a function that is both even and odd? And there's only one that I can think of, and that function is the following. What about f of x is equal to 0? This would satisfy all of these conditions because f of negative 0, this is the 0 function. So this is the line y equals 0. It's a line that lays right on the x-axis. So f of negative 0 is just f of 0. Negative 0 is 0. So then this is 0. F of 0 is 0. So it satisfies the even. F of negative 0, this is 0. We just discussed that by the same logic as this one. And then f of 0 is 0, negative 0 is 0. So this is both. Strange anomaly. Perhaps a bonus question on your exam. I'm going to step out to the side and give you a clear screenshot.